All right, so today I'm going to tell you a little bit about what I've learned about my favorite project on the lathe, which is tool handles. I'm not a real artsy guy. I like things that are practical and functional and useful. And one of the most satisfying things that I've made on the lathe is tool handles and tools. And I've probably made about 100 handles. And that's because the last several years that I was working at Volkswagen, around Christmas time, I would make a tool for everyone in my department. And so I got into production mode. This was the very first tool and handle that I ever made. It's just one of these countersink bits that you can get. And I basically pressed it into a little block of wood with some copper tubing as a ferrule. And I forget the company who makes screwdrivers that have this type of handle in England, but I thought that was kind of cool. But since then I've made, 90, 100 more handles. And I kept this first one just because. And so just to give you a couple ideas of what you can do. So we used T20s a lot at Volkswagen. So I actually just took about 20 of these and put them right into a handle. I didn't use a ferrule because it's a fairly low torque application. But of course you can use a ferrule to keep the wood from splitting. So I made about 25 of those just with that thing pressed in there. And depending on how long this piece was, I had varying lengths. A certain amount was hanging out like that. Then one year I made everybody screwdrivers. So I basically just took one of these bit holders that you might put in a drill. And then you're probably familiar that these little guys pop in there, the shorter versions, of course. And so you can just impregnate that into a piece of wood. And then you have, a 1/4-inch drive screwdriver. The other thing that I did last year that I really liked was I bought these nicer Bosch ones. That have this collar, so it's a locking version of that. Those turned out really nice. One year I did scratch awls, so I probably shouldn't have, but I bought tungsten carbide blanks. I wanted to work with tungsten carbide, and since I had a new diamond wheel, I sharpened them all on the diamond wheel. I think tungsten carbide really isn't the best choice for that, but yeah, I made like 20 or 30 awls where you just press that in the handle and you have a scratch awl. And so you can do all sorts of things like that. And it's really fun. It's very satisfying to make your own tools that conform to your hand and are the right length that you like. And I've messed around with ferrules over the years. I don't remember where I got these. I think I got these with my lathe. These are big, steel rings. You can use bushings from Ace Hardware. The cheapest option is to get copper tubing and then to just cut them to length. Make sure you deburr the inside so that you don't wobble back and forth. You can buy brass tubing for smaller ferrules or for better looking ferrules if you think the copper's ugly. All sorts of rings of any kind will do. And one of the things that I'm going to elaborate on is the lessons that I've learned, which has been many. And the first sort of challenge that you have to think about is, how do I put my hole into the block of wood that I'm going to spin or turn? And that's kind of easier said than done, depending on the length of your handle. Like in this case, it's very difficult. So drilling by hand really is not an option as far as I've determined. So the first option that you have is to drill it on the drill press, which I'll be doing for this project right now. And then there's a couple other options after that I'll get into. For longer handles like this is about 14 inches. Drilling on the drill press really is not an option. And you probably need to drill this hole with the tool on the lathe, which I'll show you how to do that in a few minutes. So stick around if this kind of thing interests you. I have to admit, I scoured YouTube looking for information and ideas and walkthroughs on how to make tool handles. And they all left me a little bit disappointed because none of them really gave me confidence that their holes were not only dead center, but along the axis of the wood. It seemed like they breezed over that part, and it was always my feeling they breezed over it because they weren't that satisfied with their result. And the reason I thought that is because I had messed with several different methods many, many times and never got quite satisfied. Or maybe they have different standards than I do and I was being too picky. The other thing is most of the examples, they don't show you how to finish the end here. That's either because they leave it unfinished, as I sometimes do, like this, which may be fine. But if you're making something as a gift and you want it to be really quite perfect, then this won't do. You can see the scratch marks, and when you try and finish this by hand, it just never quite turns out right. So I have a new method which gets it really perfect. I mean, just absolutely perfect. And I'd not really seen anyone do it before. So I'm not saying I'm the first to do it, but maybe I'll be the first to publish it, or maybe I'm not the first to publish it, but you'll be able to find it here and it'll be helpful. So let's move over to the lathe, over to the drill press. So the first challenge you're gonna have before you actually get going is finding the center of the wood. Now, there are of course many ways to do this. I have this little jig which was given to me, and I like to use it and a knife. Scalpels are a really nice tool in the workshop. If you don't have one, I'd suggest checking one out. Let me lower this down. They are very inexpensive. The blades are extremely sharp, and they just give a very, very fine cut for marking. Now, if this block were perfectly square, which it likely is not, then you could just do 2 cuts and you'd be done. But I would not recommend that, because most of these blocks are not perfectly square, even if you buy them at a place like Woodcraft, which I didn't. And it's quite difficult to get them perfectly square. You know, if you're interested in this kind of project, you might be more of a machinist than an artist like me. And under those circumstances, you know, you just might have a higher degree or a higher desire for accuracy than others. So what you call, oh geez, I'm almost doing that off camera, sorry. What you call, you know, center, I might not call center. So what you do is you make 4 marks, and then you put your point right at the center of all of those marks. Sometimes, if the wood is really off square, you'll actually basically get like a rectangle in the center here. And so you put your point in the center of the rectangle. And on the other side, whoops. So you want to get this as close as possible. Okay, now it comes to drilling a hole in this. You can use the table on your drill press, although it's unlikely to be perfectly perpendicular to the drill press. You can use a vise, which I've used semi-successfully, but my favorite method is to use some sort of a jig that you've made. In this case, I took great care in making this perfectly perpendicular. I can clamp it down to the table. I can clamp my blank here to the center, and then I'll double check it with a digital level to make sure it's just right. So I'll show you that now. This is where the first inaccuracies can start to come into the project. So you'll notice I have 3 clamps here. When you clamp this one, the bottom starts to come out. And so you'll still be able to get the hole centered, but it'll be going through the material at an angle. And depending on how severe that angle is, your 1.5 inch blank might turn into a 1 inch blank all of a sudden. The second thing to consider is in what order you'll drill and how you'll drill. So something to think about is basically if you start off with the itty bitty 1/8 like this, brad point, that's a good idea. But the speed at which you go, the faster you drill with this, the more it's going to want to wander, because it's going to try and take the path of least resistance. And if you go drilling into a particularly hard piece of the wood, it's going to want to basically bend and go around that instead of go through it. So you want to drill slowly. If you were to go just right to this 1/4 inch, or it's not quite 1/4 inch, but if you want to go right to this slightly larger than 1/4 inch, you'll probably not hit your center hole just right. So in this case, what I'm going to do is I'm going to do a 1/8 very slow to get a pilot. Then I'm going to do this one, which is 1/64 larger than a 1/4 inch. And what I do, and I've done this many times, so I have a lot of faith in it, is basically I take the measurement, because this is a hex, I take this measurement, and then I take this measurement. So basically the smallest and the highest. And there's only 1 drill bit size in between there. So basically the small one is 1/4, and then the big one is 2/64 bigger than that, and then in between is just 1/64 bigger than that. So that's what this one is. This is, let me just double check it. I think this is 17 Yeah, 17/64. So if you're doing a classic hex like this, hex bit, then 7/64 is what I found to be very useful. Excuse me, 17/64. I've used this almost 100 times. It's worked really well. And then this is 1/64 smaller than the ID of this silver collar here. That way, I'm not just relying on here and here having a friction fit in the wood, because this shank, this happens to be an impact bit, so this shank is small. So I'm making contact here, here, and then also here. And the collar pulls out, so I don't have to worry about leaving too much clearance here, although I will leave some. Okay, so last thing I want to do is clamp this down to the table, and then I'm going to use a digital level to make sure that I'm 90 degrees to everything. I will say this is a tool I wish I had bought many, many years ago. I bought it far too late in life. I thought it was gimmicky, and there's something about the construction and the advertisement that just made me feel like it was like low quality. I don't know, it just didn't scream high quality to me. But I did get one, and they're so useful, and I wish I'd got one before. So let me show you what the table looks like set up. I just want to show a really good example. I'm getting ready to lock down my table, and I want you to see how, as I lower this, the tip of the brad point tries to go into my pilot hole. And can you see how the whole drill bit shifts from left to right? So it's easier for the drill bit to deflect and bend in order to get into that little pilot hole that point that I made in the wood than it is for it to pierce a new hole. So this is a good example of just inaccuracies. We think of this as being strong and robust, but in actual fact, it's not. And it can deflect relatively easily. The other thing you want to do to increase precision is shorten up the length of your drill bits. If you have something even shorter, that's even better. But the longer it's extended out of the chuck, the more inaccuracy you'll have. You'll also see that I brought the table up very close so that the quill doesn't extend any further than it has to, because any inaccuracy that you have in a machine, which clearly this is not a super duper machine. I mean, at the end of the day, you know, it's for wood, it's not for metal, it's not like a Bridgeport or something. But you want to limit the exaggeration of the inaccuracies by limiting the movement that you have. Okay, so I've locked down my table on the post. That's important because that introduces vibrations. I have a clamp on each side. That's important because if you just do one, it'll lift. One thing that facilitates better clamping is to fill in the space underneath your table with plywood. It was a bit of a pain, and it's just up there with super glue or hot glue, but it's really nice to be able to just throw a clamp under there and lock it down without having to you know, get around these ribs and things like that you typically have under the table. Okay, so basically I zeroed my level on the post. I could have also extended the quill and done it there. And now I'm checking to see, here's what I'm clamping to, and here's what I'm clamping to. So I'm 0.2 degrees off. Unfortunately, we're working with wood. We're working with relatively inexpensive equipment. This drill press cost me like $250. So at some point, you know, you got to recognize it's not a Bridgeport. But now we'll do the drilling. And again, I'm gonna go very slow because I want it to be easier for the drill bit to cut the hole than it is for it to bend into a softer piece of wood as it goes, you know, through the grain. All right, just before I made the cut, I found that as I was clamping, it got a little bit off. Instead of trying to unclamp and reclamp, just use a hammer and tap your jig to get it just perfectly in line. That'll give you the best results. All right, let's do the drilling. want you to see the minor inaccuracies that we have. You're going to see the drill bit deflect as I go into the hole. Again, you're not going to be able to get things perfectly, but just to be aware of all of these little things, the deflections, the bending, those are things you want to be aware of. You won't be able to eliminate them, but you can reduce them. And if you are like me, I used to think like, oh, this is metal, it's not going to bend. But metal does bend and does deflect with force. And it may be in our minds very little, but at the same time, especially when you're trying to make a long tool like this, being off 1 or 2 degrees will really show up in the end product, and you'll be pretty disappointed in your work. Well, please excuse my dear Aunt Sally. In math is used to remind us of certain operations. It's very important when you're drilling to think about which one are you going to do next. If you do this one next, the small one, that's probably the right choice, although the big one can be grabby when you go in. If you do the big one first, then the end that the big one leaves behind might not be enough to keep this one centered. So you have to think about those things when you're doing drilling operations, and sometimes it's best to just experiment on another piece of wood. Once pointed out to me that your eye is able to see 3/1000ths of an inch. And we know that because your eye can actually see the light reflecting off of a single piece of paper. So your eye can be a pretty good judge for determining accuracies in places where you can't measure. And this is just a simple example. I tried out the position of this basically 1/4 inch bit several times, and I can see where it's starting to drill, and I can see that it's dead center over that 1/8. One thing you cannot rely upon, especially when you have everything clamped, is for the 1/8 to properly guide this drill bit through the hole. There's just too much stress in the system that this bit will just cut a new hole. So this provides a guide, but you still need to take care to get it just right. All right, we got the holes drilled. Now, just a quick comment. Some of you may be looking at this and saying like, oh, it doesn't need to be that precise and you're taking way too much time to drill the hole. And for shorter projects, that's probably true. But for a 12-inch handle with, a 10 inches of blade hanging out, small mistakes will basically ruin the project. And so what I would suggest is to practice your accuracy in small projects so that you learn lessons that will benefit you in longer projects, more important projects. I would also recommend not hammering this into place. I mean, if that's all you can do, that's fine. It's a little bit better to press it into place because the wood is still compressible, and so you can still get this, even right now, even if your holes turned out good, you can still get this part wrong. I know because I've done it. Okay, so this is what we have now. Now, one thing I will say is you, of course, have the choice to drill the hole and then make the tool, or make the tool and then go make the hole. I think it's almost impossible to try and turn the tool and then drill the hole. I've tried it. It works to some degree, but I would call it quite unsatisfactory. So then what you can do, if you have something like this, is you can put it into a drill and you can spin it, and you can see, visually you can see how you did. It's probably hard to see on camera, but since I've done so many of these, I have a sense that that's quite good. It's certainly good enough for this. So now I'm going to take you over to the lathe and show you a couple other options when it comes to drilling the hole. Okay, what I did in the past is everything I just did, but I wouldn't press this in. And I would just take the hole that's in the wood and I would put it on the tailstock like this, but without the tool inserted. Now, there was a couple reasons I did that. One reason is because I didn't always have something round like this to go into. Sometimes I had a Torx bit hanging out the end. The problem with that is just because you have this thing centered over here doesn't mean it's not like this, okay? And the only way to know what the other side is like is to use that center point that you did before. But that center point was referenced off of this shape, and this center point was referenced off of this shape. And these things sometimes covered in wax, and they're not square. And And so that's a somewhat unreliable method. It's an option, and I'm not saying you can't do it. I'm just saying it's not the best option. Now, the last thing I want to talk about is if you don't have a drill press, or if you would rather do the drilling on the lathe, you have a few options. I'll explain them now. Okay, this is one of the classic examples that you see on the internet, and yet I really don't have a lot of faith in, nor have I had a lot of luck in, and I've tried many times. So the classic example is do all of the work on the lathe and don't introduce the inaccuracies of another tool. So you chuck your blank and then you drill it from this side, you know, with the tailstock. There's a couple problems with that. First of all, this is like a $2,500 lathe, maybe even more than that, I don't know. I got it from a friend used, and I didn't pay that, but this is a very good lathe. And I suspect most people don't have a lathe this good, and for most of my life, I have not had a lathe this good. I bought a special $30 tool used to line up this with this, because they need to be coplanar, I think that's the word. They need to be in the same axis. So it means not just do the two tips need to touch, but they need to be correct in this way and in this way. And it's not that hard, it's not that easy to get a lathe to that point. Now, the problem with a setup like this is that any inaccuracy in the headstock in this direction or in this direction or in the tailstock will be exaggerated by this adapter, this chuck, these jaws, this piece of wood, this very short drill bit, which if you do this, you need to use a short drill bit. Don't try and use a long one. This chuck, this taper, so on and so forth. And so you have all of these inaccuracies that are exaggerated and multiplied. And so again, it's just my experience, but this has really not worked well. And I've watched very carefully on YouTube the people who use this method. They don't really ever show or prove to you that the end result is very good. And what I mean by that is when they're done, you know, they don't ever prove that this blade is in perfect alignment with this handle. And I don't know if it's because they're hiding it or they don't think to show it. I'm not trying to criticize them. I just know that with this method, I have rarely gotten satisfactory results, and the people who are using it don't seem to prove that the results are satisfactory. So that's just my 2 cents. Last option for drilling on the lathe. This is a great option. I've used it many times, and so far as I know, it's really the only option for cutting a hole in a really long piece of wood like this that you might be using for a lathe tool. So what you do is you would mark the center point of the blank here, and you would put that center point into the brad point tip of your bit. Then what you would do is you would take your rest, your tool rest, and you would line it up so that this blank cannot rotate. I'm kind of doing it really quick for the camera. But basically what you would do is you would get this thing perfectly lined up. Even better if you want to put it in the tailstock here so that you get rough dimensions. Then what happens is as this starts to turn, the blank wants to turn like this, but it runs into the rest. And what's nice is you can look down through the rest into your base, into the bed of the lathe, and you can get this very accurate. This is the best way to drill holes in very long blanks. I've used it probably 8 times. It's worked really well. I would not recommend doing this on a drill press at all. I have failed miserably, even with great thought and consideration. And so this would be my recommendation for long blanks. Oh, I forgot to hit record, so it's already done. Honestly, it only took me about 5 minutes to make this shape. I'm getting ready to do the sanding. Quick tip on sanding: if you want the best possible finish, don't sand while the lathe is spinning, because then you're sanding primarily against the grain. You want to stop the lathe and sand like this with the grain throughout the grits. I don't always do this. It depends on the project, how important it is to me, and how perfect I want to have it. But what I do want you to notice is that in the headstock here, I have a like a Jacob's chuck, and I've grabbed a short Phillips bit, which is inside the screwdriver chuck or collet, and then I have the tailstock over here. The nice thing about this is that when I'm all done and I'm ready to finish, all I have to do is move the tailstock away, and I can finish the sanding on the butt end and get a perfect finish. And I don't have to change the orientation of anything. So I'll show you that next. All right, so I'm done with the sanding. I'm going to turn down the speed of the lathe to 500, and then I'm going to pull away the tailstock. And again, because I haven't changed anything on the tool, everything's nice and lined up. Now this wobbles a bit because there's a little bit of slop here. That's just because of the way the tool's made, but it's stable enough that I can sand the nib off of the end relatively easily. Probably take even up to 1,000. Now, if you don't hold it here with my hand, it'll wobble real bad. But if you hold it, it works fine. And this is my preferred method because without something like this, you're left doing this nib by hand, which is an option. It just takes a while. But as I mentioned, I've probably made close to 100 tool handles. And once you have made a tool handle where the nib is gone and it's perfectly sanded, it's so satisfying. You really don't want to go back to leaving the nib, and you don't want to do 100 handles by hand, so it just gets really old. Get some fresh sandpaper. So I'm not going to record this whole thing, it's kind of boring, but I'll come back to you in a minute. All right, one of the most satisfying moments, of course, is putting on the polish. I've been using this gritty wax that I got when I bought the lathe from a friend, and it's got just a little bit of abrasive mixed in it, so you get kind of the final polish with it. So I sanded this up to 600 grit, and I basically sand it like this with a piece of sandpaper while it's spinning, and then afterwards I turn off the lathe and I go with the grain. So I kind of do cross grain with grain, then I go to the next grit level, cross grain with grain, next grit level, all the way up to 600. I guess I've done stuff higher than 600, and I've certainly done a lot of things lower than 600, but I have these little bits of sandpaper on a roll that go from 150 to 600, so I always just do a little bit of each. All right, and I'll just take it off. And hopefully you can see that the back is perfect. No nibs, no knobs, no swirl marks. And, you know, of course it's not important that that's nice. I mean, it's a tool, it's meant to be used. But when you have found methods where you can get that perfect, it's hard to go back to a method where you leave an ugly little nib. And you notice there's no ferrule on this. I've made probably 15 like this, and none of them have broken yet. So I realized for this size and dimensions, you really don't need a ferrule. And I got this shape kind of from Lee Nielsen. I used to be more into hand tool woodworking, and I bought Lee Nielsen's screwdriver like this just to kind of see what a really high quality screwdriver would look like. And I've tried to make screwdrivers that are of that same quality. So, all right, well, I hope that was interesting or helpful to someone who's interested in this kind of thing. I'm more of a machinist than I am a woodworker, and so I approach a lot of topics with probably an abnormal amount of precision or desire for precision. So some of this might be overkill for a lot of people, but like I said, when I was looking to do it, I was a little disappointed with what was available on the internet for tips and tricks to really get things perfectly in alignment and to get the ends just right without a ton of handwork. So hopefully this will help someone who is in my position. All right, if you didn't like that, give it a thumbs down and check out a guy named Stuart Batty. He's the best woodworker I know. I've learned a lot from him, and I bet you will too. Take care, folks.